All right, welcome to class, everyone. Can you guys hear me okay?
Yes.
All right, great. Good. All right, well, welcome to our first class of the semester. Uh, Looks like everything's working with the Zoom and Canvas. Um, so let's get started here. It's 11:30. Let's go ahead and look through some of our documents that are on Canvas, and hopefully we'll even get started with some discussion of statistics today. So everything is pretty much here in Canvas already for you. I see that at least a few of you have gotten started with with some of the homework. So there's a lot in the orientation here. There's a lot more that I'm going to cover today in class, but I would like you to start by clicking there and kind of working through the orientation. We have some of our documents in here and kind of an introduction to the class, and just kind of introduces you to how things will work this semester. There's also a calendar in there, so if you work through the orientation, you'll find this calendar. And let's have a quick look at this. I think it's worth printing this out and having it at hand, so you're aware of what's going on in class. These are not due dates. These are what we're going to be talking about in class on various days, at least what we have planned for those days. Um, so as you can tell, pretty much every day we'll cover one or two sections from the textbook, and then you'll have homework from each of those sections. And I usually will have the due dates for the homework a day or two after we talk about them in class. You have a couple days to work through the homework after we talk about it in class. Um, so the homework will be done online through a program called Lumen OHM, and that's free to use. You don't have to pay or buy a key for it or something like that. It's linked in through Canvas. I'll show you that in a little bit. There are 4 midterms. Okay, so these midterms have to be proctored, and it can't be like an online proctoring service. So you might have seen some of those online proctoring like Proctorio. We don't use those in the math department. So these 4 midterms and the final have to be taken at one of the Salt Lake Community College proctoring centers, testing centers. And so as soon as I get those exams submitted in the next couple of days, you can start signing up for a time to go take the exam. So typically I give you 2 or 3 days to take that exam. And I find that that kind of helps with people's schedules, makes things flow a little bit more easily for the class. So 1, 2, 3, 4 midterms, and then the final will be that second week in December. Okay. And the final exam will also be proctored at one of the Salt Lake Community College testing centers. Now, if you live outside of, far away from Salt Lake City, if you live in southern Utah, or if you live out of the state, then we do have arrangements with other schools that we can make to, so that they can serve as a proctor. And the information for that is in Canvas. Let me just go ahead and, since I'm talking about it, let me go ahead and show you that here. Let me see, where is that? Okay. Yeah, it's on this page called Testing Center Information for Online/Live Stream Courses. So for most of you guys, probably most of you guys are, fairly close to Salt Lake City. And so you'll sign up for one of the Salt Lake Community College testing centers. And so there's a link here for that. And I haven't submitted the exams yet, so I don't think you'll be able to sign up today, but in the next couple of days, I'll get those all submitted. And then if you're living, further away from Salt Lake, then you can do what's called a remote proctor. So you can use like a library or another college or university for that. Okay, so in the next week or so, you'll want to go ahead and get all of that set up. Okay, so what else do we see on the calendar here? So 4 midterms, a final exam. We see the holidays here. There's 6 chapters we're going to go through. Roughly 1 or 2 chapters will be on each exam. The final is comprehensive, so it covers chapters 1 through 6. Okay, so there's midterm exams, there's a final exam. We also have chapter quizzes. So here you see the chapter 6 quiz, chapter 5 quiz. So there's roughly 1 or 2 quizzes for each of the chapters. Those quizzes can be found in Canvas. If you have any questions, just feel free to speak up, or you can put a question in the chat. So if you're new to Zoom, there's a chat button somewhere on the screen. If you look around, you should see a chat button, and you can chat to the whole class, or you can chat to me privately if you have a question. So let me show you where to get to those quizzes. So if you come over here to modules and scroll down, each chapter will have 1, sometimes 2 of these quizzes. Okay, so for example, the chapter 1 quiz, it's here in Canvas. You'll click in there, and it's got, typically a quiz will have 5 to 10 questions or so, and they'll look very similar to what you see in the homework. Okay, so about 1 or 2 chapter quizzes for each chapter, 4 midterms, final exam, and we also have homework. So again, if you come over here to modules, and then, for example, 1.1 homework, we're going to cover 1.1 today. So after we finish this, you'll want to jump in and get started with the 1.1 homework. So for this section, it's a pretty short section. There's only 2 questions. Okay, so this one is multiple choice, but some will be kind of more typical math questions where you enter in numbers, etc., right? Or writing. But yeah, so expect about 1 section of homework for each section from the textbook. And they can vary. Sometimes there's 10 problems, sometimes there's 30 problems. And I believe it should be set up so that you can resubmit problems until you get it right. So, with enough time, you should be able to get a really good score in the homework if you put in the time for it. Okay. Let's see, what else did I want to go through? We have a project. Okay, so the project is an important part of the grade. So if we come over here to modules, again, we can look at the project. So let's see here. There's 4 parts to the project plus a reflection part. So it says 5 parts, but really there's 4 parts where you're doing statistical analysis. And it roughly corresponds to the 4 midterm exams. So this part 1 TB data project will be very similar to the stuff you saw first midterm exam. And TB stands for tuberculosis. There's 3 or so different projects that we've put together for this class, for the 1040 class. I chose the tuberculosis project because, well, to me, it's the most interesting of the 3 projects. And I know from experience teaching this class that commonly many of the students who take this class are interested in some kind of branch of medical science, health sciences. So I think it's especially relevant for a lot of the students. So it's the TB tuberculosis data project, and it's split up into 4 parts plus a reflection. At the end of the semester, you'll take all of those, put them together, and put them on an e-portfolio. And there's more information about that on the Canvas website. So if you haven't done an e-portfolio yet, you'll want to read up on that and ask. You can talk with me as well if you have questions about the e-portfolio. But it's basically a website that every student will maintain and use it as like a suppository, as a place for keeping projects and other impressive work that you do in these various general education classes you take at the college. Okay, so there's the project here. We have quizzes that are done through Canvas, the homework, the 4 midterms, and the final. Let's see if I'm missing anything else here. I think that was all. Yep. Okay, so you can see the grade breakdown here. The homework is worth 20%, so about a fifth of the grade. Chapter quiz is 5%. The biggest category is the midterm exams. So there's 40%, 40% of your grade is coming from that. So each midterm is 10%. So, uh, so any one midterm isn't going to drastically change your grade, but, you know, um, put together, that does form a big part of the grade. The final exam is a quarter of the grade, and then the signature project is 10%. And I will, at the end of the semester, replace the lowest of your midterm exams with what you get on the final if it helps your grade. Okay, so if you do well on 3 of the midterms, but you do poorly on 1 of the midterms, and then you do well in the final, I'll use that final score to replace the lowest of your 4 midterms. Okay. So I think I've shown you pretty much everything here. Do you have any questions about the course? Did anything come to mind? Any question come to mind as we were talking about any of these things? So one thing I just thought of, let me just explain a little bit about the different kinds of courses we have at the college. We have the traditional on-campus courses. Okay, so 20 years ago, this is pretty much all we had. You'd go to school and you'd go to a classroom, you'd sit there and, interact with other students and your teacher. And we still have those classes. They're still quite common. About a half of our classes are still on campus. Then 15 years ago, the online courses started becoming more popular. So these are often called asynchronous because they don't meet at the same time. You don't really meet with other students or your professor. You meet with them in group chats and work on assignments together, but you're not in a room together or in a Zoom meeting together. Okay, I got a question here from Sam. He says, what happens if you can't make it to one of the Zoom classes? I will record these Zoom meetings. So, well, let me say this. It's set up to automatically record. Okay. Now, Zoom is a good technology. It doesn't always work. So if you miss class, it's probably going to be recorded for you, but sometimes it does something weird and it doesn't record. Okay. So typically, these classes will be recorded. So if you miss class, you can watch it on Zoom, on the Zoom recording. Does that answer your question, Sam? Okay, so back to our little history here. So there's the on-campus, often called face-to-face course. Then there's the online, and then during the pandemic, we piloted and came out with this live stream method, which has become pretty common. It's still not nearly as common as the first two, but that's what you guys are taking here. Okay, so this is different than the old online asynchronous model. This is synchronous. We're all meeting together here in Zoom at one time. So, it's assumed, I'm assuming that you're, taking the class so you can meet with us, twice a week during our normal class time. Okay. Now, am I going to take attendance? Am I going to force you to be here? No. So, if you want to miss class occasionally or if you have to miss class because of, this or that, that's okay. Just make sure you watch the Zoom recording. But if you plan on like never coming to class and just watching the Zoom recordings, I would recommend, instead of taking this class, I would recommend that you take the online class. Okay, so if you can't come to pretty much every class at 11:30 to 12:50 Tuesday and Thursday, take the online class. Okay, I mean, I'd love to have you in this class. I'd like to have as many students as I can, but if you're not if you're not going to be synchronous with us, right, on Tuesday and Thursday at 11:30 to 12:50, then the online class is probably better for you. Okay, it's just a little bit, more designed for students who aren't meeting together. Okay, there's more videos, there's more discussion assignments, and it just works better for a pure online course. Okay, so if you can come to pretty much every class here in Zoom, then you're in the right place. Okay, I like the live stream model. I think it works well, especially for that subset of students who do well with Zoom and don't need to be like in a physical classroom together. Okay, I do think it's a good model, and I've been teaching this live stream pretty much once or so every semester for the last few years. I like it. I think it works well. So, but again, if you don't want to come to class every Tuesday and Thursday, really you want to switch over to an online class or maybe in some other format. Okay, good. So I just want to say that. Then let's talk about the textbook and the lecture notes. So if you come back over here to the home page, and right down here it says textbook. So let's see, I got a question in the chat. Okay, so let's see. Question is, I was a little late to class. Even though this is a live stream class, if I need extra help, do you have office hours, or is there a place to find help or tutoring? Yes, great, good question. So, so there's two. So if you're not seeing this in the chat, it's because this was sent to me directly. So when you put questions in the chat, you can send the question to the whole class or just to me. Okay, so yeah, so let's see, two questions. Yes, I do have office hours. My office hours are on Monday and Wednesday at 12:30 to 2:30. Okay, so you can see that down here. So there's my name. I'm John Schweitzer. Here's my, whoops, my phone number. My office is at the South City campus. So if you want to come and meet with me in my physical office, I will be there Mondays and Wednesdays from 12 to 2:30 at the South City campus. If you do want to meet with me during my office hours, just shoot me an email, before you come to the office, just so I'm sure I'm there, because often what'll happen is people don't come to my office hours for the first few weeks of the semester, and then I'll go and get coffee, and then somebody like comes to my office when I'm out of the office or something. So anyway, just shoot me an email if you're coming to my office, and I'll be sure to be there between these hours, Monday, Wednesday, 12 to 2:30. Okay. If you don't want to come to the South City campus, then you can come to my virtual office, which is here in Zoom. So it's different than this Zoom classroom. So the Zoom we're in right now, obviously, is the Zoom that's dedicated to this class. But I have another Zoom that's my virtual office. Okay, so the link is there. And so same thing, if you want to come to my office hours, 12 to 2:30, just shoot me an email the night before or the morning of, and just say, hey, I'm coming at this time, and I'll be sure to be there. Okay, so to meet me in my virtual office, you'll just click on that link, and as long as you've told me you're coming, I will be there. Okay. But otherwise, I don't like sit there with my Zoom on for a couple of hours. So if you don't tell me you're coming, I probably won't be there. Okay, in the Zoom office. All right, and then the other question was, is there a place where I can get tutoring help? And the answer is absolutely yes. Okay, so if you go to the SLCC STEM Center, we have free tutoring, and it's drop-in tutoring. So you don't need an appointment. Let me show you this real quick. So the Taylorsville, the Jordan, the South City, and the Harriman campuses all have one of these STEM tutoring centers. Now, some of the centers are larger than others, and the larger centers probably have more generous hours. So for example, the Taylorsville campus, it's 9 to 9. okay, Monday through Thursday, and then Friday a little bit shorter. The South City campus, it's 10 to 5, okay, and they're not open on Fridays. So still very good hours at the South City campus and the Jordan campuses, but just not quite as much, right? So I would go there and, come to my office hours, and then if you need more help, then definitely go and see one of the tutors there at one of these STEM centers. Good. Any other questions? Okay, so where was I? Textbook. Okay, so yeah, come over here to the textbook um, place there and click on that. And this is a book that it was a book we basically edited and rearranged, and we wrote some new sections for it. So it's a free textbook in PDF form. And if you need uh, a more accessible version, we have two versions here of the textbook. And so it's here, and I don't really use it too much while I'm in class. I think it's a great resource, and I think you should read it. But I typically won't really be pulling it up and using it too much in class, except for today. I will use it today. But anyway, so that's there, and it's available for you. Um, it's this IISRS, and yeah, we put it together, and we like it very much. If you want to get a hard copy of it, then they're available at the bookstore. I don't know how much it is. I think it's under 25, so it's pretty affordable. But that's what it looks like there. And so if you like PDFs, then I would just recommend using the PDF version. If you want a paper copy, you can print it off yourself, obviously, or run down to the bookstore and get a copy there. Probably even more important than the textbook are these guided lecture notes. Okay, so oh, and then let's see here. Devin's got a great comment over here. He's saying there's also online tutoring if you can't make it to the tutoring center for any reason. So yeah, let's see what's going on with this button here. The 24/7 online tutoring. Sometimes they have more of this, sometimes they have less of this online tutoring. So let's see here. Let's see what they're saying here this semester. Kind of changes from semester to semester. So yeah, it does look like we still have this tutor.com option. So I believe they give you like 8 free hours every month. So if you log into there, set up an account, they should have good tutors there available at the tutor.com. So it's an external company that we partner with, that we hire basically to help out with tutoring. So good. Thanks for mentioning that, Devin. Okay, guided lecture notes. So with statistics, uh, it's a little bit more verbally heavy than maybe some of the other math courses. So there's a lot of writing, there's a lot of definitions, and what we found over the years is that lecture notes, follow along lecture notes, are really the best way of delivering the material for this course. So I use these lecture notes every day in class, and I highly recommend that you do as well. So if you download that, you'll see this document here. So the Introduction to Statistics Guided Lecture Notes. And again, it's just a really nice way of presenting the information, and a lot of it is left blank. And I've written in some of the things, other things I'll fill in as we go through our discussions. And if you just kind of follow along and fill in the blanks and take notes, I think that's the best way of taking notes for this course. That said, I'm not going to require that you do it. I'm not going to check in and make sure you're using them. If you want to use, typical, like blank notebook, like you would for many other classes, feel free to do that. However you want to do the lecture notes. But I think it's a very good way of organizing the information. Okay, so both of those are available from the Canvas homepage here. So again, guided lecture notes and then the textbook. Okay. So it should be recording all of these lectures. So our, our daily class will be recorded typically and available in Zoom. But we also, when we were putting this course together a couple of years ago, created a ton of videos for students, 253 to be exact. Okay, so what we did is once we had everything all put together, we looked at the book, we looked at the lecture notes, we looked at the homework problems, the test objectives, and we sliced it up into a bunch of different pieces and made videos for all of those things. And so they're here at this YouTube page, and I highly recommend that you use this. We have the the lecture notes here. So I hate to say this, but basically the work we're gonna do in class every day has already been done here in these lecture notes videos. So this lesson 1.1 is more or less what I'm gonna be doing today in class. So again, I feel a little bit weird saying that, but it is here and available for you. So if you miss class and you'd prefer, then you can open up the YouTube video here and use it to fill in the lecture notes. Then we have another playlist here for exercises. So there's additional problems you can work through and practice with. We have some software guide videos here. We have videos by learning objectives. And it's just tons and tons of videos here. Okay, so we know students love videos, learners love videos. They're very useful for doing certain things. And so we made them and they're available here for you. And I highly recommend that you use them. Okay, any other questions or anything else that's come to mind as we've talked through this? Anything else I can help you with? All right, well, let's get started here. We do have some course material. In fact, we've got to get through 1.1 and 1.2 today. So there's no time to spare. So yeah, let's get going here, 1.1 and 1.2. So if you haven't done this already, go ahead and download the guided lecture notes and open that up. And let's get going. So you hit the PDF there and it'll open up these lecture notes. Oh, one other thing to help you make sense of these lecture notes. There's another class here at the college called 1045. Okay, so there's Math 1040, which is Intro to Stats. So that's this class. Then we also have 1045. And what it is it's Intro to Stats. It's all of what we're going to study, but it also includes some algebra and some study skill discussions. Okay, so it's designed for students. Maybe they haven't had a math class for a while. Maybe they feel weak in algebra or maybe just in math in general, and they want some help with algebra and maybe learning some study skills, getting recommendations for how to study math. And so it's our intro stats class, but it has additional information. By the way, if that sounds like it might appeal to you, we have lots of these 1045 classes. In fact, I'm teaching one of them this semester. So if you feel like that might help you, you might want to switch from our class to one of these 1045 classes. Just an idea. Of course, I don't want you to switch, but if it would help you, then it might be a good idea, right? So if you feel intimidated by algebra or you haven't had math in a while and you find math intimidating, the 1045 might help you out because it's the same material, but it adds in some additional algebra information, okay, and study skills. So the reason I'm telling you about this right now is that the lecture notes will have these algebra and study skills built in, and they don't apply to 1040. So we're going to skip them. And so I'm just telling you that you can skip some of the stuff in these lecture notes, okay? And so if it says study skills, skip it, unless you want to learn about study skills, in which case do it. but I'm not going to be talking about it in class. Okay, and so same here. I'm not going to be talking about time management in class. I would in my 1045 class, but we're going to skip it, right? Growth mindset. Not going to talk about it in this class, but it's available for you. Okay, so we're going to start here on page 4 with the introduction to data. Okay, so I've taught this class so many times over the years, and I've heard this same comment from students over and over again about chapter 1. Chapter 1 is it's like a setting up the conceptual framework for statistics. So it's highly conceptual, got lots of definitions, and not really much like mathematics. We're not really going to be calculating too many numbers or statistics here. It's mostly a vocabulary it's a framework that we'll be using for the whole semester. So lots of definitions here. And so probably the most important would be data. Okay, what is data? Well, data are observations that are collected from field notes, surveys, experiments, and just about anything else, any other way of collecting data. So it's observations. Okay, statistics is a study. I think of it as one of the branches of math that studies how to best collect, analyze, and draw conclusions from the data that's been collected. Okay, so we're going to collect data, we're going to analyze it, and we're going to draw conclusions from the data. And so each of these steps is actually a really, really huge topic. Okay, so people will spend their whole careers thinking about collecting data. It's called sampling theory. Okay, others will spend their whole career developing visualization techniques for helping them analyze data. Others will spend time thinking about how to take a sample and draw a conclusion about a population. That's called inferential statistics. Okay, so stats is a huge and it's a very broad field. And yeah, so, but this is a nice way of thinking about what it is we do in statistics. Okay. So for the overall kind of framework for how we think about a statistical process, we came up with this 6-step process. Okay, so some textbooks might use 4 steps, others might use 7 steps. So, exactly 6, that's not super important, but we thought that this was a nice way of thinking about all of the important steps of a statistical investigation. Okay, so the first thing we're going to do is we're going to identify a question or a problem. Okay, so that's the first thing we always do. We have some question that we're trying to answer about the world. Okay, so something's happened and we're curious about it, or there's some problem that we're trying to fix, and so that's the beginning. We've identified something that we want to work on. Then we're going to design a study and collect the relevant data. Okay, the third step is we describe the data. Okay, so that's typically done with tables, graphics. Okay, the fourth step, we're going to perform a statistical analysis. Okay, there's not really much I can show you here about the fourth step because it's day 1 of the semester, so we don't have any statistical analysis techniques yet, but that's typically the fourth thing. The next step is to take the analysis based on the sample and make an inference about the whole population. Okay, so that's the 5th step. And then the 6th step is sort of is kind of a conclusion step where we look back over the study that we did or the one we're reading about, and we think about potential problems with the study, weaknesses, strengths, and if we're going to do further study, we use that previous study to make a plan for further research. So we call that the contemplate and consider. Okay, or some people would say look back and look forward, something like that. Okay, and so these are some nice words, right, describing a process. So I want to look at an actual study that was done and use it to show you these 6 steps, how they would work in a real study that was done. So go ahead and open the textbook, or at least download it. And I want to have a look at a journal article describing a study that was done. So to get to the textbook, you come to the home page and then textbook. And then it's this introductory statistics with randomization and simulation textbook. So ISRS. So download that. And let's open that up. And I'm going to come over here to page 2 of the textbook. Okay. This was a journal, an article, a scientific article that appeared in the New England Journal of Medicine. So the New England Journal of Medicine is one of the top, maybe the top medical, scientific medical journals in the country. I mean, it's a very prestigious journal. And so, it's a real study that was done. And what they were looking at is stents. Okay, so are you aware of stents and how they work? Well, let me show you a picture of a stent and what it is, what it does. How does it help? What is it used for? Okay. Well, this number 1 picture here represents an artery. Okay, so the arteries in your body, right? They carry the blood around, and as you age, they tend to have some cholesterol buildup. Okay, especially depending on what kind of diet you have. You might have less cholesterol buildup, you might have more, but this is quite common to have this cholesterol buildup, right? So as you can imagine, if you get enough of this cholesterol buildup, it can block the artery, and that's not good, right? And in fact, sometimes it gets so bad that you can have a cardiac event, right? You can have a stroke, right? Or other things I'm sure can occur if you have enough of this cholesterol buildup. But what they were looking at is strokes. Okay, so typically a stent would be used after somebody's had a stroke. Okay, so the way it works is a stent. If you look down here in the 4th graphic, it's basically a wire mesh that's a tubular wire mesh. And the way it's used is inside the wire mesh, they'll put a balloon, and inside the balloon, they have a wire. Okay. And so they collapse the stent and the balloon down. So it's small, right? They can slide it in the partially blocked artery. Okay, so it's in place there on 2. You can see that. Then in step 3, they inflate the balloon. Okay, and then when they inflate the balloon, it expands the artery. Okay, and then you don't want to keep the balloon in there, right? So they have they have a way of removing that wire and the balloon there, and the stent remains. Okay, so the stent expands and it stiffens, right, and it holds that artery open so that the blood can flow, right? And so these are used after somebody has had a stroke. So there's no question that these work. Okay, maybe not for everybody, but on average they do work, and it's medically accepted that these are quite useful. And so this paper wasn't looking to see if they're useful for people who've already had a stroke. This paper was looking to see if they're useful for people who are probably going to have a stroke. Okay, so they were looking at this stenting. They were looking to see if this can actually prevent strokes. Okay, so we know it works after somebody's had a stroke, but they're trying to see if it works for preventing strokes, right? So you wouldn't put this in like a healthy person with no history of cholesterol issues or heart problems. You would be using this on people who are in poor health and who are at risk for having some kind of cardiac event. Does that make sense? Okay, or at risk for having a stroke. Okay, so does the idea make sense about stents here? So let's use this to think about our process of statistical investigation. Okay, so we have 6 steps, and let's go through them. Okay, so we're going to identify a question or a problem. Okay, so that's our first step here. Let's go ahead and do that. What is the question, the problem that we're trying to identify? Okay, so do stents reduce the risk of stroke? By the way, during class, you know, I kind of have to jump from document to document. Sometimes I might pause part of the screen and then I'll forget to unpause it later on, just because I'll have to pull up documents or something. And so if I'm ever working on something and you suddenly get the feeling that you can't see what I'm writing, it's probably because I've forgotten to unpause something. So please let me know as soon as you can, you know, if it looks like it's not working on the screen. So often it'll happen, I'll get like 10 or 15 minutes into a discussion and I'll have paused it like 20 minutes ago and it's just much easier if you can catch it earlier. So if it looks like something's not right on the screen, just let me know as soon as you can. Just put it in the chat or just kind of speak up out loud and let me know. Okay. So anyway, okay. So that's our first question. That's identifying the question or the problem. Okay. And I mean, I think that's quite a useful thing to answer, right? I mean, uh, strokes are, you know, can be, you know, life altering and even deadly. So if we can prevent these, or at least some of them, that would be great, right? So it's a very noble and worthy question, right, to be able to answer here. The next step is to design the study and collect the data, right? So we're going to design a study and collect the data, right? So how did they do that? Well, if you read the article, there were 451 volunteers, and these were all people who were at risk of having a stroke. Okay, again, it wouldn't make sense to put this into healthy people. So these were all, you know, people who had been identified as being at risk for having a stroke. And then they randomly assigned 224 to get a stent and 227 to get no stent. Okay, so the no stent is called a control group. And why would we have that? Why would we, you know, you might think, well, it's kind of wasting our volunteers, right? I mean, we're only getting 224 with the treatment. You know, why would we waste, right, 227 of the volunteers? Well, it's not wasting actually. In fact, it's very important to establish a baseline, right? So with that control group, we're basically getting an idea of um, you know, among this group of people who are at risk, the likelihood of them having a stroke, even without the stent, right? So that control group is very important. They provide the baseline versus which we can, you know, compare the treatment group to them, right? Okay, and it's also important that this was random assignment. Okay, so they basically used a computer to generate random numbers, and 224 of them got treatment, 227 got control. Okay. So what was going on with these two groups? Well, the control group got management. Okay. So basically they consulted a doctor, they consulted a nutritionist, you know, exercise scientist, right? And they had a management plan for their high cholesterol problem, right? You know, their poor health, right, condition that they're experiencing. You know, just because in the control group, it doesn't mean we want to, you know, not give them any care at all, right? So they were on the standard health management program, the one that is, you know, typical for people who are at risk for strokes. The treatment group got health management. They got the same health management program, but they also got a stent. Okay, so that's also another important piece we want to have. We want to make sure that the two groups are as similar as possible, except for the treatment. Okay, all right. So there we go. That's the design of our study. And then they basically collected data for a year on these people, right? So what's the data? Well, did they have a stroke or not? Okay, so that's our next step. We're going to describe the data. By the way, if you have any questions, just let me know. Okay, so love to answer any questions you're having here. So the data appear here in the book. Let's see, where did it go? Hold on one second. Where did my data go? I guess it's back up here. Yep. Oh, there it is. Okay, good. Yeah, so this is a typical data set. And what we're looking at is, so it's like a spreadsheet, right? Often appears like a spreadsheet. Each row is an individual. So each row is one individual in the study. This is very common for data sets. So this first row here is the first patient, and the data set has all of the information that was collected about that patient. Well, probably there was other information collected, but the relevant stuff here is, these pieces of information here, okay? Each column is a variable. So the columns typically, not always, represent a variable. What's a variable? Well, a variable is an observation. It's a piece of information that's collected, but it can be different from person to person, okay? So the first variable of interest is group, okay? So there's two groups, okay? This first patient got the stent, right? That's what it means to be in the treatment group, okay? So the first variable there is what group are they in, okay? So the first row, that's the first patient. The first column is, after the patient number is what group they were in. Then we have the 0 to 30 days, okay? So we have the outcome for the first month. So for this first patient, they did not have a stroke in the first month. And then in the final column here, this is the first year. They also did not have a stroke. So that's good. That first patient, they got the stent and they did not have a stroke. The second row is the second individual. It's the second patient. So this person was also in the treatment group, which means they got a stent. Unfortunately, this person did have a stroke in the first 30 days. Okay, so since they had a stroke in the first 30 days, they also, that means they had a stroke in the first year. Doesn't mean they had like two strokes. Maybe they did, but probably it just means, they had a stroke in the first month, so therefore they had a stroke in the first year, right? Okay, ... The ellipsis, that means, hey, look, we don't want to put in 451 rows of information here. We just need a few lines to get comfortable with the data set. So we're going to have ellipsis here to jump over the middle part of the data, and then we'll conclude it down here. So 450, that's patient 450. That's also an individual. They did not receive a stent. Okay, they're in the control group. And the first month after not receiving the stent, they did not have a stroke. And in that first year after not receiving this stent, they also did not have a stroke. Does this make sense? So this is a very typical looking data set where rows represent individuals or observational units, we'll sometimes call them, and columns represent various variables. Okay, so very typical looking data set. Okay, and that's one of the first things you do when if you're an analyst and you're looking at data or somebody else's data, you just kind of make sense of what it is that they've collected. Okay, so there we go. We described the data, and what were the results? Okay, well, in our treatment group, there were 224 people, and of those 224, 45 had stroke. So about 20% of those people had a stroke in the treatment group. Okay. In the control group, There were a few more people in there. They kept it pretty well balanced, but sometimes with these studies, people will drop out of the study, or maybe data will be lost. Something kind of happens. So it doesn't have to be exactly the same in both groups. 28 of these people had a stroke for an incidence rate of 12%. Okay, so what do you guys think? Are stents helping with preventing strokes? We know they help after somebody's had a stroke, but should we be using these to help people prevent strokes? What do you guys think? I know it's Zoom and it can be a little bit harder to recreate, like a classroom discussion, but it does work here in Zoom. So feel free to just unmute yourself and chime in, throw a question or a comment in the chat. What do you guys think? Do you think that this was proving that stents are good at preventing strokes?
Probably not.
Probably not. If anything, it looks like the stents are making it worse, right? I mean, 20% is more than 12%, right? So the group of people getting the stent, the treatment group actually had a higher rate of strokes than the control group, right? So definitely this is not arguing for using stents to prevent strokes, okay? So good. And it would be great if they prevented strokes. In fact, that would probably be the best outcome, right? So you have another tool to improve lives, but at least they've answered, perhaps they've answered a question here, right? So it's still useful knowledge and useful study that they did here, right? So a couple of points. First point is sometimes the results of a study can surprise you, right? We were probably expecting the stents to help, right? And definitely we probably weren't expecting them to harm people, but maybe it appears like it's harming people here, right? Okay, good. So let's perform a statistical analysis. Okay, now this is day one of the semester. We haven't really studied stats much yet, so there's not a whole lot that we can do here at this point. Most of it is going to be kind of using common sense. Later on, we'll have statistical techniques that we can use at this point. But anyway, we can still think about this. So let's do a statistical analysis. Okay, so first of all, 12 minus 20, 12% minus 20% is 8%. Okay, so the stent group did 8% worse. Okay, so that's the first thing to take away. They did worse. The second thing, though, is, and this is another thing we're going to be talking about pretty much every day for the rest of the semester, is this a real difference or is it an illusion? Okay. Is there a real difference between the two groups, or is the 8% an illusion? Okay, or we could call it a sampling error. 451 people is a relatively small sample, right? I mean, there's a lot of people out there who are at risk for having strokes. Probably tens or maybe even hundreds of thousands of people are at risk for having strokes. And we didn't do this experiment on all of them. We only did it on 451. And, I think it's just intuitive that because we're taking a sample here, there's going to be it's possible that there's some kind of randomness going on, right? And maybe we just got a bunch of people in the treatment group who were, maybe in poorer health than people in the control group, right? And maybe it was just a weird selection and we just got a bunch of sick people in the treatment group and more relatively healthier people in the control group, right? So I think it's at least possible that if we did this again, we might see differences, right? That 12% might be higher if we did it again, and the 20% might be lower if we did this again, right? And that would make the difference less, smaller, right? And maybe it would even flip, right? So, I mean, I think if you're being honest with yourself, you can agree that it's at least possible that the 8% is just due to chance. Okay, so I just want to ask this question: is it at least possible that the 8% is due to chance? Okay, and I think I think the honest answer to that is yes. Okay, if you think it's a no, then maybe you're right, but we don't really have a way of proving that it's a no at this point, right? I think if we're being really kind of open here, open-minded, broad-minded here, I think we can say it's at least possible, right? So the rest of the class is really all about trying to answer this question. Okay, so that's the rest of the semester, so we're not going to do it right now. I'm just going to kind of leave it there hanging for you. Let's get on to the next step here, inference in context. Okay, so we're going to do inference now. So we're going to take this study and we're going to apply it back to the whole population. So what did the authors conclude? If you read the paper, the authors conclude evidence of harm. So they decided that 8% is probably a real difference. And it means that stents as a preventative for strokes are causing harm. Okay. Afterwards, sure, we know they work. That's been proven in previous studies. They're not questioning that. They're just trying to see if it helps to prevent strokes. And they're saying no, in fact, it makes it worse. Okay. So what do you guys think so far? Is this making sense? So we got our 5 steps here. I love this study. I mean, it's super useful, and I think it's interesting and applicable. And it really does show these 6 steps quite nicely. So what's the 6th step? It's contemplate and consider. Okay, so anytime you read one of these studies, especially if you end up being a researcher yourself in the future, you're going to want to contemplate and consider what's going on with the data. So just let me give you an example. Is this really a good sample? Okay, these are volunteers after all, right? Who volunteers for medical studies? Okay, often these are, often people conducting these studies will be giving money, right? Paying people to participate. So, it might be people who are needing money, right? And maybe they have more medical problems than the rest of the population. Who knows, right? Or maybe these are, good Samaritans who are willing to participate in a study. It's not really clear that volunteers for medical studies are always good representative samples of the entire population. Does that make sense? So we would want to, dive a little bit deeper into what the sample looks like. Maybe we should look at other variables, right? So maybe we should look at other variables, right? Maybe things like age. Are these 2 groups similar age, right? Did we get maybe older people in the treatment group somehow and younger people in the control group? We should probably think about things like health status. Mobility is often another big thing here. I mean, if people are too, if you can't, transport, if you can't get transported, right, it might cause some kind of weird, sample effect where we're only getting a certain type of people, right? So there's all sorts of things that could go on here. And then let's see, we've got a question here, a comment from Shoshana. I wonder how old the subjects are and whether they are male or female. Great, yes, so gender could have a role for sure. We commonly see gender effects in medicine. So there's just lots of things to consider. And the other thing is to think about other kinds of stents. Okay, so every stent in this study was the same kind of stent. This was, if you read the details of the study, this was the Wingspan stent by Boston Scientific. Okay, so it's another, maybe this one particular stent isn't very good at preventing strokes, right? Maybe they should redo this study and consider other kinds of stents, right? So these are all things to contemplate and consider. But they did, in this particular study, say, hey, we probably shouldn't be using stents to prevent strokes. Great. All right. So any questions there about that study? We spent a little more time than I should have, but it's a great study, and I think it gets us started on the right foot here this semester. Any questions there about that? Let's keep going. We got 20 minutes. Let's do our own study. Why not? Okay. Now, many studies often require time, right? I mean, the study we just looked at, they took at least a year, right, to get the results back, and it probably took at least a year or so before to prepare everything and get everything set up. And it certainly costs a lot of money to do that, right? So lots of data sets require time and money and other kinds of effort to collect. We don't really have a lot of time, right? We got 19 minutes here, and we don't want to spend a lot of money here. So we chose a variable that was pretty easy to collect in class. So let's think about eye color for a little bit. So there was a poll that was done by the Harris organization. So the Harris Polling Organization is a widely respected and prominent polling organization. And they do all sorts of polls ranging from politics to economics, and in this case, eye color of all things. And they said that 45% of Americans have brown eyes. And what I want to do is a 6-part study very quickly to think about the results of their study, right? So there's 6 parts here, right? 1, 2, 3, 4, 5, 6, corresponding to those 6 steps, right? So the first step is identify a question or a problem, right? So does the proportion of people with brown eyes in your class support Harris's claim? The second step is we're going to design a study and collect relevant data. So here's our design. I am going to ask you what your eye color is, and I'm going to ask you to put it in the chat. Okay, if you don't want to participate, that's perfectly fine. But if you're willing to participate, that'd be great. So there's 2 types here. There's brown eyes and then everything else. Okay, so if you have green eyes, I don't need to know you have green eyes. Just say brown or non-brown eyes. Okay, so I have brown eyes, mostly brown eyes. So I'm gonna put myself over there. And if you would just put your answer in the chat, I'll give you a few minutes here. We'll collect those values. And again, I really appreciate if you participate. So we can have some nice data here, and we'll get our study going, okay? So take a minute there to, oh, I see, that's cool. So somebody put their tally mark in there already. Okay. All right, so IJ, I think you have that green one on there. And then, so I don't know who put the red one in. If you, well, it's probably easier if you just put it in the chat. I hate to do this, but I'm just going to erase those other ones just because it looks like it's in the chat and then it's also in the tally, so it's kind of tough. So let me just kind of reset all this. Sorry, I should have been clear there. Just put it in the chat. It's just we don't want to double count anybody there. So I'll put mine in as well. So I'm brown eyes there. Okay, right. I think that's everybody. So let's see. Okay, so let's count up the non-brown here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm seeing 9 non-brown eyes. And then for the brown eyes, let's see here. 1, 2, 3, 4, 5. Okay, so good. That's 14. Zoom is telling me there's 14 people in here, so that looks right. Okay, so there we go. We've collected the data. There are 14 of us in here. And so there we go. Okay, so there we go. We've collected the data. Now we're going to describe the data. What percent has brown eyes? Well, 5 out of 14, right? 5 out of 14 gets us our proportion. So let's see, that's going to be 5 divided by 14. So we're looking at 36%. What do we round it to? It just depends on what it is you're doing, really. There's not really a golden rule for rounding. So let's see. So Devin's saying our sample is so small. Good. Yeah, if we had a larger sample, it'd probably be different. And so yeah, that's exactly what we should be saying in the 6th step here for the contemplate, right? So we have a small sample, and that's definitely something to consider. Good. Okay, so is the 36% the same as 45%? Nope, it's not. Does it seem close enough that 45 the difference is just due to chance? Okay, so the claim from Harris is 45%. Our class average is 9% different, right? So there's a 9% difference. Could that just be due to chance, or do we have really strong evidence that Harris is wrong? What do you guys think? Could it just be due to chance, yes or no? Let me hear what you guys think. It's the same question as the last problem.
Yeah.
Is that difference possible? It's an illusion, right? Good. Yeah. So 36 is actually close to 40%, right? So does our class support the claim that 45% of Americans have brown eyes? It doesn't support, I wouldn't say that it supports it, but it doesn't refute it either, right? It's not really definitive either way. That happens a lot with studies, by the way. They're not really definitive. It's just kind of, it's not clear, right? And that's fine. So why doesn't it? I mean, it is different than 45%. So why does it not refute the Harris study? Well, the first problem is that it's a small sample, right? And later in chapters 3 and 4, we're going to actually look at formulas for sample size. So statisticians, they want to know, like, how large of a sample do we need? And there's formulas that tell us that. And we'll see the formulas soon enough. But just intuitively, 14 is I think everyone would agree that's such a small sample. Anything else that might be a problem here for us? What other things do we want to contemplate and consider here about this study? Is this really a representative study? Probably not, right? If you're looking at the whole population, you've got people who are newborns, right, ranging all the way up to people in their 90s and even beyond that, right? I'm pretty sure, well, most of the people taking classes at the college are not, children, right? I mean, none of you are like 5 or 1. Most of you are at least 16 or 17, right? And probably we do have some senior citizens who take these classes. My mother actually takes classes sometimes here at the college. She's in her 70s, but probably most of you guys are probably under 60, I would imagine, right? So it's not really like it's not really a representative sample just based on age, right? So it's just not a representative sample, right? So the sample is not representative really of the entire population. Okay, and as far as I know, all of you guys are in Utah. Sometimes I get live stream students who are in Australia and Switzerland, or Canada, but usually, you guys are pretty close to Utah. So it's not really broadly representative of the whole country, right? So does that make sense? Good. So is it a serious study? No, but it really does show us the the 6 steps pretty nicely. So I like doing that. Any questions there about that? Okay, so some more about data. All right, so as we've said, the observational unit is the same as an individual. So it's the person being observed. Typically, it's typically a row in a data set. Okay, variables are the characteristics, the changeable, characteristics of observational units, right? So somebody might be 6 foot, somebody else might be 5'11", somebody else might be 5'7", right? So it varies, height changes. The data set is how we structure it. So the rows typically correspond to observational units and the columns typically correspond to variables, right, as we've discussed. Okay. Then we have a 2-part classification for data. So broadly speaking, data can be quantitative or it can be categorical. Okay. So what's categorical? Categorical, we're talking about categories. Okay. And sometimes some textbooks will call this qualitative data. I'm fine if you use that word, but categorical is considered a little bit more technically correct and common to use. Okay. So we have categorical and quantitative data. What's the difference? Well, quantitative, I typically think of it like this. If you can count it, if you can measure it with a ruler or measure it with a scale, then it's probably quantitative data. And if it's not one of those 3 things, then it's probably categorical. Okay, let me give you an example. Yeah, I mean, categorical, that might be something like gender, right? Okay, so gender is a category, right? So that would be categorical. Okay, your weight would be quantitative, right? So how much you weigh is quantitative, right? So something like weight would be quantitative, whereas gender would be categorical, right? So I want you guys to try these other 7 here. Each one is a type of data, right? So we could measure temperature, nation of origin, number of siblings, number of days worked, right, for various individuals. And so the information collected would either be considered categorical or quantitative. So I want you guys to try these real quick. Okay, so just put a C for categorical or a Q for quantitative next to each of these 8. I'll be quiet here for a couple minutes and let you work through those. All right, temperature, quantitative, right? Okay, nation of origin, so you come from the US or Canada, right? These are categories. Number of siblings, well, it's a count, right? You count up how many siblings you have. So it's quantitative. Number of days worked, well, you might have worked 5 days this week. You might have worked 1 day this week. That's quantitative. Okay, grams of carbohydrates in a donut, quantitative. Phone number is actually a category. Yes, it's numerical, but it's not, it's not like a count of anything. And same with zip code, those are both categorical. So you can be numeric and categorical. Where do we go from there? Well, quantitative can be divided further into 2 types. Okay, so quantitative, there's 2 types of quantitative. There is the discrete and there is continuous. Discrete in mathematics doesn't mean that you can keep a secret or something like that, right? Discrete in mathematics means that it doesn't make sense so much when you start dividing it down. Okay, what do I mean? Well, think about the number of windows in the room you're in. Okay, so you're probably in a room somewhere, right? And that room has some number of windows, right? So just count up the number of windows in your room right now. Okay, in my room, there's one window, right? Uh, maybe in somebody else's room, there's two windows. Maybe in somebody else's window, there's 0 windows, right? So if we put those numbers on the number line, they would be discrete dots on a number line, right? Nobody has 2.5 windows in their room. You might have a tiny window, an unusual window, but you never call it like half a window. Well, maybe you would call it, but it's still just a window, right? So you start getting these gaps between the values, the possible values in your data set, right? That's what it means to be discrete. Okay, and so that's what we mean by spaces between the numbers. Okay, so if you put all the values in your number line, right? If I just asked you all to tell me how many windows are in your room, we'd get a bunch of dots on the number line: 0, 1, 2, 3, 4, 5, maybe 6 or 7, but nobody would say 2.3 windows. It just doesn't make any sense, right? So you get these spaces between the numbers. That's what it means to be discrete. Continuous is something like weight. Okay, so let's think about possible values for weight. Can I weigh 170 pounds? Yes. Unfortunately, I weighed 170 yesterday when I checked. Okay. Could I weigh 171 pounds? Yes, it's happened. What about 171.5? Yes, it's possible, right? What about 171.55? Yes, that's also possible. What about 171.555? Yeah, if I had a nice enough scale, that would be possible, right? My bathroom scale does not give me 3 digits of accuracy, but if I went to a chemistry lab or a physics lab, they might be able to get this to any level of accuracy, right? So my point is that all of the possible weights would actually cover the entire number line. That's what we mean by continuous. There's no spaces between the values on the number line. Okay, so let's work through these next 8. It might take me a couple of extra minutes, but let's just work through these real quick. Okay, so each of these 8 are quantitative. They're all quantitative. Some are discrete, some are continuous. Okay, so let's think about flipping a coin 5 times and counting the number of heads. Okay, well, you can get 0 heads, you can get 1 head, 2 heads, 3 heads, 4 heads, 5 heads. You can't get 2.3. So this is discrete. Shoe size is also discrete. I'm not talking about the length of your foot. It's related, but it's different. When you order a shoe, it's either 8, 8.5, 9, 9.5, right? You know, typically you don't order 8.3 or something, right? Okay, so they have these discrete shoe sizes. Distance Tiger Woods can drive a golf ball. Well, that's continuous because, again, he can drive it 451 yards. He can drive it 451.5 yards, right? There's no real limit to values there for a length. Points scored in a basketball game. You can't get fractional points in a basketball game. You can get 1 point, you get 0 points, you get 2 points, but you can't get 7.8 points. Volume of water lost each day from a leaky faucet, that's continuous. Length of a song, continuous. Number of words in a song, well, you count the number of words, right? So, typically that would be discrete. Advertised price of a pound of apples, that's probably also discrete because how much would a pound of apples cost? Maybe $2.98. maybe $2.99, but I've never been in a grocery store where it was $2.98, 5, 6, 7, 8, something like that, right? They always clip it off at 2 decimal places. So we could consider that as a discrete variable. Okay. There are some values, like with money, for example, there, where it's sort of it's a little bit gray, right? Is it discrete or continuous? And really, at the end of the day, for some of those cases, it doesn't matter too much. The reason we consider difference between discrete and continuous is it tells us what kind of statistical technique we're going to use. Okay, so so for those really gray cases, it's kind of like we're splitting hairs, and it doesn't really matter that much, because with money you can treat it either discrete or continuous. Okay, but the overall idea is important, this discrete versus continuous, because it'll determine what kind of technique we use. Okay, we're out of time for today, so I'll stop there. And this is all we had to do today anyways, 1.1, 1.2. So we're in a good spot. Are there any questions here for me or for the whole class here as we end for our first time together? We'll jump into Canvas, work through that orientation, and then on Thursday, come back with any questions you have, or feel free to email me. And yeah, have a great day, and hope you're off to a good start here with your semester. See you all on Thursday. Take care.
Thank you.
Great. Thanks. Thanks, everyone.